So, number 4. The arithmetic mean of 5 numbers is 85. When 6 is added, the new mean is 75. What's the sixth number? So, in order to find this, we need to find the sum of the first 5 numbers. In order to do that, we're going to go 85 times 5. We're just reversing how to find mean. So, 85 times 5 is 425. And then we want to find the sum of the next set of numbers. So, 75, there are now 6 numbers. It's going to give me 450, and to find the number that was added, we go 450 minus 425, and I get an answer of 25. Moving on to my next one. Alright, right at the bottom there, just missed it. What is the product of the range, median, and mode of the following sets? Our product means to multiply. So to find the range, again, that's the easy one, highest minus lowest, which is 8. The median is the middle number. Because there are 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 numbers, we're going to find the middle of the 5th and 6th numbers, which will be that guy right there. The middle between 5 and 7 is 6. And the mode, the one that is most often, is 5 right there. Is going to be 5. We want to find the product of those things. So we are going to multiply 8 times 6, which is 48, times 5. 48 times 5 equals 240. This is the algebra, sorry, we'll go to the next one. So what is the greatest common factor of 18 and 24? Question you've asked yourselves multiple times, I'm sure. Let me go to my answer for this. The greatest common factor between 18 and 24. Well, we're going to move this over a little bit, just give myself some room. We've got a few ways we can do this. Is that we can actually go through and we can find the factors of 18 and 24. Which is going to be the way that I did it. So I went through, I found the factors, and I said that there is 1, 2, 3, 6, 9, 18 go in here. Over here I know that 9 and 18 don't go in, but 6 does, which makes 6 the greatest common factor of this. How many factors does 18 have? So you list out the factors. And you count those up, and you also get 6. How many two-digit numbers are there whose digits have a sum that is a perfect square? Remember, perfect squares would be like 4, 9, 16, 25. So we're just going to go ahead and list things. So 1 is also a perfect square as well. So we're going to go ahead and list out what we see. So are there any numbers that add up to 1? Yes, there is. 1 and 0. Excuse me, let's move this over a little bit. So, numbers whose sum is 1, I have 10. The next perfect square is 4. Numbers that add up to 4 are 13, 22, 31, and 40. Numbers whose sum is 9, I get 18 or 81, 27 or 72, 36 or 63, 45 or 54, and then 90. Sum of 16, I get 79, 88, and 97. And let's just try 25 for good measure. Well, the highest two-digit number I have is 99. 9 plus 9 is 18. We don't quite get here, so this is going to be too big of a perfect square. Now if we go ahead and we count all these up, I've got 1 here, I've got 4 here, I've got 9 here, and I've got 3 here, so I said there are 17 two-digit numbers who have a sum that is a perfect square. Express 2007 as a base 6 numeral. This is exciting. So I see that if I take 2007 and I divide it by 6, because it's a base 6 numeral, okay, it goes in there 334 times equally. So I've got 2007, we're dividing by 6, okay, I'm left with 334. I have some remainders here, with a remainder, we're going to have a lot of remainders actually. The remainder of 3. So now if we divide 334 another time here by 6, sorry, 334. Then we see that I get 55 with a remainder of 4. And if I can divide 55 by 6 again, I'm going to get 9, remainder of 1. And then I can divide again, and I get 1. Ooh. I get 1 with a remainder of 3. And I'm going to take these numbers right here and put that as my base 6. 13,143 base 6. We haven't learned that. We can talk about this in class when I get back from C Camp if you have any questions about this one. And last, express the binary number 111,001 base 2 as a decimal base 10. So first off, I need to think about my binary numbers. So I'm just going to go ahead. Binary is just this right here is a computer code of 1s and 0s. It's kind of cool actually. But I'm going to go ahead and just write this number out a little bit longer. What we have to know about binary is that every number that this is right here is going to be the next power. In this case, it's with a base of 2. So this first guy right here is 1 times 2 base 0, 2 to the 0 power is just 1, so 1 times 1 is 1. This one over here is 2 to the first. This guy then is 2 squared. This guy then is 2 to the third. It's 2 to the fourth. And is 2 to the fifth. Now with all of these numbers that I have here, we are going to find the sum between all of them. So if we go through and do that, 2 to the fifth is 32 times 1 is 32. Plus 2 to the fourth is 16 times 1 is 16. 2 to the third is 8 times 1 is 8. 2 to the fourth is 4, but times 0 is 0. 2 to the 1 is 2, but times 0 is 0. 2 to the 0 is 1 times 1 is 1. And so we add that up, and we get 57. The pages of a magazine are numbered from 1 through 50. How many times was the digit 3 used? Simplest way to do this is to go through and just write out every time you see 3. So you're going to see 3, 13, 23. You're going to see a bunch of 30s. And you're going to see 43. If we add all of those up, we get 15. What is the least common multiple of the numbers 8, 12, and 15? Well, to find my least common multiples, we're going to list out what are my multiples of each of them. And so we have 8, 16, and so forth. I have 12, 24, 36, and so forth, 15, and so forth. We can start with some easier things and knowing that the 15s are going to end, it's got to be on a 0. There's no way that 8 or 12 are going to make a 15. So when I'm talking about my 15s, I have to think in terms of zeros. So 30, 60, 90, 120, 150, and so forth. I want to think, okay, does 12 go into any of those numbers? Does 12 go into 30? No. Does 12 go into 60? Yes. Does 8? No. Okay. Does 12 go into 90? No. Does 12 go into 120? Yes. Does 8 go into 120? Yes. And so we get 120 as my final answer there. Another way that we could do that is by some factor trees. And that we are going to look at the factors of 8, 12, and 15. So 15 has I can go 3 and 5. And then over here I know that I can go 3 and 2. And then over here I know that I can go 3 and 4. I can go 4 and 2. Because I have the 3's multiple times, I don't need those. The 4's, I only need 1, excuse me, only need 1. So, and the 4's, I only need 1, 2. So I could go 4 times 2 times 3 times 5. And that'll also get me 120. Number 8, how many prime numbers are greater than 50 and less than 100? Remember that prime numbers are numbers that cannot be divisible by anything besides 1 and itself. And so we're going to talk about just divisibility rules. And so as we go through from 50 on up, we have to think about anything that ends in 0 or 2 is automatically canceled out. Any number whose 2 digits, such as 51, add up to a multiple of 3. In this case, 5 plus 1 equals 6. Because this is a multiple of 3, that is then divisible by 3. Same if I had 5 plus 4 is 9. This is now divisible by 3. So 54 would be divisible by 3. So I'm going to use those rules to help me out for that. So I can cross out all of those. If I think about other divisibility rules, if 2 goes into it, then yeah. If I do this, then I'm going to come up with 10. We're just going to go through and we're going to list things as we go through them. If it ends in a 5 or 0, obviously 5 goes into that. You can do your 9 trick if you wanted to, but the same thing would be for 3's. For number 9, a palindrome is a number that reads the same forward as backward. How many 3-digit numbers are palindromes? Well, we are going to talk about, I know that I need my first and my last numbers to be the same. Now, this could be 101, 111, 121, and so forth, down to 191. If I do that, I'm going to see that I'm going to get 10 of these numbers. I know that I have 100, 200, and so forth, up to 900. And so then there are 9 things, 100, 200, and so forth is 9 times I can do that. So I get 90 numbers that satisfy that. What is the unit digit of the number named by 3 to the 207th power? Well, what we're going to do is let me figure out what I did with my notes here before I explain it to you. So excuse me. We're going to stop here.